everyone, welcome back to your channel Technology Incredible. Today we will see problem number 13 from the lead code, that is Roman to integer. We have to convert the Roman numbers to their integer value. We have to return the integer value for that Roman representation. Okay, this is an easy level problem. Let's check out the problem. First, they have given the representation that Roman numbers are represented by 7 numbers. That is, these are the uh, symbols in which Roman numbers are represented. Okay, they have also given the corresponding values for those symbols. For example, 2 is written as II. Okay, this is how 2 is written. Just two ones added together. Now, how 12 is written? 12 is written as 10x plus x, and after that 2i. And one thing is that that's 12. Okay, the largest symbol will come first. The representation is largest to smallest, which is then 12 is simply x plus ii, that is 10 plus 2, that is 12. Now how number 27 is written? 27 is written as xx, 10 plus 10 plus 5 plus 2. Here also it is from largest to smallest. 10 are the largest from all this, and then comes smaller one. The next thing they have written is Roman numbers are usually written largest to smallest. That's only thing I have said. However, the numeral for 4 is not 4. Okay, 4 is not written as 4i, but it is represented as I and then 5. Okay, this is how 4 is written. Uh, 4 is written as I and 5, not this. Okay, this is wrong, but this is right. Now next, what they have said that however the numbers for 4 is not 4i, instead it is written as this I and 5. Because the 1 is before the 5, we subtract it, making 4. How we determine its value? We determine its value as, because 1 I value is less than this 5. Okay, for I value is 1 and for 5 value is 5. Okay, for V value is 5. But 1 is less than 5. Okay, this is 1 and this is 5. But as we know that in Roman number we are going from largest to smallest, but here it is smaller one is before the larger one. So we will subtract it in a total value. Minus 1 plus 5. This is how it becomes 4. Okay. That's only they have written here that I can be placed before V and X. These are the two symbols before I can be placed. Then X can be placed before L and C, because X can be placed before L and C. Okay. And C can be placed before D and F. D and F. I can be placed before V and X. L can be placed before C and D. And C can be placed before D and F, like this. Given a Roman number, convert to an integer number. We have been given a string S, which is the Roman number, and we have to retain the equivalent integer value for that Roman number. Okay, so let's see how we can solve this. Wait a bit. Let's take the example they have given as L. Okay, this is the example they have given. Now first we will check that what is the value of L. L is 50. Okay, this is a total what we will retain as answer. Now the first we go from index 0. The value is L, and its value we check from there. L value is 50. So we add 50. Now what the next value is V. For V value is 5. So we add 5. Then next I 3 times. So we will add plus 1 and plus 1. Okay, this is the positive test cases condition, that if there is the string is in orders largest to smallest. This is in positive. But what if this will be the condition? Okay, what if this is our case? Then what we will do? Let's see. Let's see. Now this is our index 0 L. So L value is 50. Now before L can be placed before okay. L is the larger one. There is no smaller one can be placed. Sorry, no larger value greater than L can be placed after L. So we write 50. Okay, L value is 50. Now next come I. Okay, we know that I value is 1, but we will not add directly 1 here. We will check that after I is because I can be placed before V and X. Is there V or X after I? Yes, there is V. So we check for I plus 1 index, that here we got V. So what we will do? We will subtract this value of I. So we will subtract this value. So it will become 50 minus 1 plus value of V. So it is covered. Now we check the next index. It is I. Now again we check, is there again at I plus 1 index value is V or X? No, it is I only, so we will add it. So now for this our value will become 49, okay, 54, 56, 56. So we will retain 56 for this string, like this. So let's check. We can go from 0th index to the last index, and we can also traverse backward. Okay, so I have solved in both ways. Let's check out the solution in Python. First, I have defined the dictionary for all the symbols and their values. So I is 1, like V is 5, X is 10. Okay, like this. Now here in this I am traversing from 0 to last index. Okay, so I have first taken I is 0, then total, which we will retain at the end. Total value in the starting before traversing is 0. I have initialized it with 0. Then while loop will run till I is less than string of s for this complete string. Okay, for this complete string, this while loop will run. Now what we will check? We will check if I is less than length of s minus 1. That is till this value, this length of s minus 1. We will check this if condition, that is dict of r s of I is less than dict of r of I plus 1. Okay, is the value at index this is less than this index? This we will check here. If it is less than, then we will subtract the value. We are subtracting the value. Total minus equals to dict of r s of I. Okay, else it is not lesser than the next value, then we will simply add it in a total value and we will increment I by 1. This is how we are doing it from starting index to ending index. Okay, now I said that we can do from end index to the starting, we can come last index to first index also. So that's I have done. Let's remove the commented. Now first what I have done, I have initialized the n value, length of s. Okay, first I have initialized the n value, then I equals to n minus 1. I am traversing from the last index. I equals to n minus 1. N is the length of the string, I equals to n minus 1. Then total will be 0. Okay, initialize the total value which we will return, that is 0, initializing by 0. Then we are, while I is greater than 0, we are traversing backward last index to first index. Okay, so till I is 0 or greater than 0, we will check the values for simple. Now, if I is less than n minus 1, we will check this for boundary condition. That is it is last index? Okay, till I is less than n minus 1, then dict of r of s of I is less than I plus 1 is value before uh, uh, value at index is lesser than the next value. If it is lesser than, then we will subtract the value, else we will add the value in total, and then we will decrement the counter because we are traversing from last to the first index. Now at the end we are returning the total value. Okay, that's how you will solve all the problem. This is the first, from first index to the last, and this is the backward tracing. Okay, thank you.